from this equation, from this formula? I wonder.
Know the object distance more easily.
To know object distance more easily? Not easily, actually, not easily. We designed the camera. We designed the camera to make it the image distance exactly as the focal length. And if you put that to this equation, what does it mean? What does it mean? Deborah? Any thoughts? No. From the equation, it's not like that. Yeah. Angie? Mama? To take a better picture. What do you mean by better picture? Well, in general, it's correct. In general, it's correct. To take a better picture, a more clear picture, yes. But why? So why is like that? So,
maybe there's no object distance.
there's no object distance. Of course, there's object distance. 郑勇
Because object distance is larger than image distance.
Alright, so you probably need to speak louder. Alright, so speak. Talk about it again.
Because object distance is much larger than image distance.
Alright, so in this case, as you can see, if your object distance, if let's say image distance equals to focal length, this is focal length, and in this case, this term over here, the whole thing should be 0. If this needs to be 0, means that the object distance needs to be very, very large. Alright, so in this case, like I said, satellite camera, usually we just set the image distance as focal length because the object distance is large, is much larger than the image distance. It's much larger. For example, like you can say, well, one is like a few hundred kilometers away from the object, and the other one is just few meters. So it's very, very large difference between them. So in this case, you can just directly set the image distance as the focal length, so that you can take clear picture. Okay. So aerial photo as well. Most of the time, if we want to simplify the process, and then we usually also set the area, even if it's an area, the camera on the area for the area photogrammetry, we also want it to be the image distance as to just set the image distance as the focal length. So to simplify the processing, to simplify the process. Okay, so that's one thing that we can discuss over here. So yeah. All right. So here the reason that we need to use so right now the reason that we need to use multiple lenses compared to just one single lens is actually because of these two reasons. One is to minimize the aberration. Aberration means in Chinese it's called 色相差，色彩的色，相是相片的相，差是差异的差，色相差 aberration. So the reason for the aberration is because different wavelengths actually has different refraction angle. Different wavelengths has different refraction angle. What's the evidence for that? You guys should know it actually. Rainbow is one example. Rainbow is one. Or the Alright, so Newton has something like this, right? And you are reflected, and even more reflected, right? So why? Because different wavelengths has different refraction angle. So in this case, if you only have one single lens, and then in this case, those different well, the wavelengths of those energies for different wavelengths will be spread out. And then in this case, the image will looks a little bit blurry. In this case, the image will looks a little bit blurry. So you can use multiple lenses to kind of refract it more and more, and then to make those light rays, they will eventually reflect to the same light ray. So that's one of the reasons to improve the image sharpness. And the other reason is to reduce the lens distortion. So as this is much easier for you guys to understand. So if you only have one single lens, then you can imagine that for the age of the image, it will be have large lens distortion. And so you can use multiple lenses to lower down the effect of that, right? To do that. So you to maintain the better geometry. So yeah, just like that. Oh, we don't have example. Yeah, so basically try to imagine that. Oh, you can find some example online. Okay, so here is this is the image geometry for the thickness. I think we didn't talk about this. So if you have thick lens, it doesn't matter how many lenses that you have, but usually we will summarize them into 2 points. One is the front nadir point and rear nadir point. We kind of talked about that, but not in detail. So we have these 2 nodal points, not nadir, nodal points. In Chinese, it's called 节点，节是打结的结，密字旁那个结，打结节点。Alright, so their behavior is like this. If you have a light ray pointing at this the front nodal point, then this whole light ray will be this whole light ray will be directly shift to the rear nodal point, and then using the same angle and then pointing at the image plane. So it's like I don't know, it's like a portal over here. So you just go from here and then shoot out from here. Okay, so that's the behavior between them. Front nodal point and rear nodal point. In Chinese, it's called 前节点跟后节点，前跟后 front here, front and rear. Alright, so yeah, that's the image geometry. And usually the principal points that we talk about, the principal point that we talk about is the rear nodal point. It's this one instead of this one. The rear nodal point is the perspective center. The perspective center that we're talking about. Right? Okay. So exposure fall-off, that's what we mentioned earlier. So the center is brighter than the edge, and then we can have a formula to talk about that. But however, this is the you can say theoretical formula, the cosine quadrant. Quadrant? I think so. Okay. So anyway, so the formula is like that. But however, in reality, if I remember it correctly, it's not so large. It's like cubic to like square. In reality, it's just like that. It's not like reduced so much. Okay. So why that formula looks like that? Well, you guys can take a look at this. So here is the aperture, and here's the aperture, and then here's the image plane. So the more light ray that you can, the more energy that you can get is from from this direction. So everything can be collected and then pointing at this pixel, you can say. And then here for the H, then you have less inputs because you have some tilt angle here. And also you need to travel farther to your image plane, so that's the other reason. And the third reason is that this information needs to be spread out to the pixel. So that's the third reason that it's become you can say becomes has less energy, has less exposure on the image plane. Okay, so that's pretty much about the reason of that. And in this chapter, actually, the main thing is talking about the image density, intensity, those things. So here, actually, it has multiple terms, and you can take a look at by yourself. including, for example, illuminance is the function is affected by aperture, shutter speed, and also the focal length. But however, the image intensity, the real intensity, is not only affected by the illuminance, and also it is affected by the emotion sensitivity, which is how sensitive your self-film, how sensitive is your film is. So that will decide the image intensity. So yeah, for example, aperture larger, then you have more energy, and then focal length longer, you have less energy per unit area. So eventually, this is the you can say relationship. The brightness on the image is like proportional to the shutter speed, and then to the this D is the aperture. So the larger of the aperture, then the brighter that your image will be. And here actually we have something called f-stop and also f-damper. So if I remember it correctly, it's like the f-stop is here. F-stop is the focal length divided by the aperture. So on some of the camera the single lens camera that you have, and sometimes there's something called f-stop, and sometimes it's f-damper. Then you can directly just change it, and that actually it indicates the relationship between the focal length and also the aperture, so that you can adjust the exposure for the image. Okay, so that is used in some of the in some of the cameras. Okay, so that's it. I think that should be enough for you guys. Alright, so the other thing that I didn't mention before is called depth of field. This is called 景深 in the depth of field. So basically, it means that, let's say, in the past, I believe you have seen some images that like I believe it's called poetry poetry mode. When you use, for example, like your cell phone to take a photo, and if you are taking a photo of a human being, and you want to make the person to look more clear, and the background is blurred, and then it's called poetry, right? I think that mode is called that. And so, or sometimes you see I don't know. In the past, I would call it like small flower mode. There's sometimes it's the small flower, and then you can just focus on something that is clear, and then whatever background is blurred.
Macro. Called macro.
Macro. Oh, I don't know what's the name for that, but sometimes it's just show as a small flower, so I just go small flower mode, something like that. But just for me. Okay. Anyway, so that's a professional term, so don't remember that. Okay. So anyway, that is by controlling the depth of field. Right. So what exactly is the depth of field? It's the end of focus area when the image confusion is indistinct. So which means that the depth of field is the range in the object space. That is the distance in the object space that if any object locates over here, that you will consider them as clear. You will consider them as clear on your image. And whatever object is outside this range, and then you will consider them as like blurred, right? As blurred. So, so how to control it? Actually, well, it's affected by many things. Let's take a look at the next page. It's controlled by your you can say focal length, and also f-damper, and also the distance that you focus on. For example, you are focusing on something very close, or focus on something very far away. So that also affects it. And the other important thing is this depth of field actually is defined by human being, you can say, because according to the definition is, well, it's a certain distance that you feel is clear, right? Whatever object inside that region, inside that distance, you will think this is clear. So there's one term which is called the confusion circle, or circle of confusion. In Chinese, it's called 模糊圈. Confusion, just 模糊. Okay. So the circle of confusion is this. Alright, it's this. So the B point over here, those are is the focal point where you are focusing on. Alright, this is where you are focusing on. And so as you can imagine, this if you have a point on B, then it will be 1 point on your image plane because that's where you focus on. And however, if there's one if you remove that point away from B, either to the A or to the C, if we move it away from B, then that point actually start gradually like enlarged. It start gradually enlarged. It doesn't matter it's away it is toward like A or towards C. This point this original point will become larger and larger. And to the certain degree that is larger than the circle of confusion, then you will think, okay, this is blurred, it's not clear. Alright, so the depth of field is actually defined by this. It's also defined by this. Okay. Alright, so that's the case. The other thing is, in terms of the depth of field, there are two terms or two depth of fields that you can talk about. One is the near. This is field length or near field length and far field length. In Chinese, it's called 前景深跟后景深. Alright, my memory. Alright, near field length and far field length. Alright, this one is this one is the near field length and this one is the far field length. In Chinese, it's called 前景深 and 后景深. Alright, 前跟后景深. Alright, so the behavior of these two are actually a little bit different. So if you, for example, like adjust your camera a little bit, then the near field length will be